give you just a little bit of a background on Sonic Pi. It was created by this guy named Sam Aaron, who's based in the UK, and he's a computer programmer, a musician, and electronic musician, and he wanted to make a software that he could live code with. So that means that he wanted to make a software that he could stand in front of an audience and type on his keyboard and have what he's typing be sort of recompiled and reprocessed in real time and generate music in real time. And he does this. He plays in clubs. It's really wild to see this live in action. This sort of live coding phenomenon has reached America, and there's a really vibrant community for it in New York that I have some friends in. And to go see these live coding shows, it's really wild because the music is like, it's music. It's really cool. But then the code is projected, and maybe some live generated visuals are projected as well. So it's all about that sort of intersection of arts and technology, which is sort of a buzzword, right, sometimes, but is still cool nonetheless. So I'm going to share my screen with you all, and I'm going to share this, and I'm going to make sure that this works. Okay, so I'm going to ask some questions, and you can give little thumbs up in your video screens or your little boxes, and that'll just sort of help me, get a temperature of our room here. So can everyone see this? Is this big enough for everyone?
Yeah.
Okay, great, thanks. So let me just walk you through sort of this interface, because this interface, it doesn't look like you should be able to make music with this interface right away, or maybe at all. And actually, I need to just get back to my thing really quickly, because I'm gonna, hold on, I'm gonna make one of my colleagues the host, because I think people might be sort of coming in and out, and I don't wanna miss that because I can't see that now. So Kevin, I'm going to make you a host if that's cool. There we go. Okay, now I'm going to share my screen. Oh. Okay, so now I can't share my screen. Oops, now I lost my video.
Kevin, you can allow Brooks to share his screen by hitting the arrow next to stop video. And then under video settings, there's a setting to allow other people to share their screen. Okay, you guys got it.
Okay, Johnson, I'm going to make you a host, or the host, because Evan, can you enable me to share my screen, Jocelyn?
Let me try and get that. Just give me 1 second.
Sure.
Okay, now try.
Okay, cool. Great. So so let me just sort of walk you through these different parts of the screen. So here we have sort of our main coding area. Those of you who have coded before, this looks pretty familiar. Just below it, we have these different buffers, as they're called, and you can store different bits of code here, and you can just sort of use this as a way to hold some code that you can jump back and forth in between, or have different songs or different part of your set, or a different idea or a sketch that you're working on there. Over here is your log and your scope. The scope just gives you sort of a visual representation of what's going on in your music. The log will tell you things about what's happening. You can have, you can use the print command to print things to the log, so you can keep track of things that way. Down here in the queues, that sort of works a little bit like the log. And then this box down here on the lower left is really pretty important. Has all these different things you can look at. There's all these tutorials, which are pretty cool to walk through. For those of you who play Minecraft, there's a Minecraft API thing where you can build in Minecraft and have it generate music that way, which is pretty gnarly and pretty cool. Some examples. There's all these synths. We'll talk about some of these today, and these give you all of the different parameters that each synth takes, and you can edit. Same thing with the effects. It's a bunch of different effects here. And then samples as well. This gives you sort of samples by category. So like drum samples, then it lists all the different drum samples and all that stuff. Sounds of the tabla drum, very cool. Sounds featuring guitars. And then this one here, the lang, this is all of the language stuff that you can use with Sonic Pi and sort of the definitions for some things. So it's great. Like I'm sort of more of a self-taught coder, and so I spend a lot of time on forums, unfortunately. And it sort of is a bummer to get out of your workflow and have to go Google stuff and be like, what are the parameters that are involved with this thing, or what is this thing? So it's great that it's all just right here, right in your window. So let's get started. First, I'm going to, let's see, I'll show you just one or two things that I'm working on. The sound isn't going to be great. It's going to be fine. Sonic Pi, for all of its technical wizardry, doesn't have that good of audio preferences or audio options. So like the share audio thing that's in Zoom that's supposed to take your computer's output and directly shoot it out into the internet, that doesn't work for Sonic Pi, so I'm having to just sort of mic up a speaker, which is not the best solution, and I'm going to try and figure out a better one for next time. But it's what we're working with now. So here's something that I've just been sort of working with, and then after I play this, we'll sort of start from the beginning, and I'll try to get everyone to make some music. So here's... Okay, so it's just sort of a fun generative drum beat, and if I let that play, it just keeps making all these sort of random choices and keeps generating this loop, these loops indefinitely. Okay, so let's start. Let's start like this. Everyone, if you have Sonic Pi open in front of you, just open up a buffer, something that's blank. If there's some stuff that's in it, feel free to delete it or move to a new one or whatever. But the first thing we're going to do is sort of the most basic thing. So I'm going to start with just a single loop, or just a single sample, rather. So if I say sample, okay, and then I hit a space, it comes up with all these different samples that I could use. And all these are all built in. It's sort of incredible that this free software comes with all this really great loop samples and loops that are just ready to go. So like any good electronic music producer, I'm going to start with a bass drum. And the one that I like is this BD house. Okay, so I'm going to do that. Then I'm going to say sleep. Sleep tells the computer how long this action is going to take. And so I'm going to say this is just going to be one beat, okay? And if I run that, it just does it once, okay? If I want it to happen multiple times, I can copy and paste. Okay, that's cool. If I want it to happen 4 times, I can copy and paste that. Okay, and that's cool too, but that's not super interesting. So one thing that we can do is we can change the sort of rhythm of it. And we change rhythm, when I think of rhythm, rhythm is time. So I'm going to change the sleep I'm going to keep that one at 1, and I'm going to make this one 0.5. I'm going to make this one 0.5. Now, if I run it, okay. So it would be really, it'd be really tedious to have to map out a song completely like this, right? To have to put every single hit that you want in like this, right? And for those of you who know a bit about computer programming, you can probably guess what's going to come, right? We're going to use a loop, okay? And the great thing about music and technology is there are some words that translate directly from one side to the other. So in music, a loop, right, like a drum loop, you just loop it, just keep it going, it just keeps going. Same thing in computer programming. So a loop is a block of code that gets executed over and over and over and over again until it meets a condition for it to stop. So I'm going to use the language. I'm going to say live loop, and then I have to name it. So I put my little colon there, and I'm going to name this one bass drum. Then I'm going to say do. Now, the cool thing about Sonic Pi, Kevin and I were talking about this sort of before we started. A lot of programming languages get really caught up on colons and semicolons and parentheses. And did you end this line with a colon or a semicolon, or is this indented correctly? Or, all these sort of, really particular language things. Sonic Pi is a highly abstract programming language, and so there's not a ton of that. There are some things like that and some things that we need to watch out for. And so one of those is whenever we use a loop or whenever we have sort of a block of code, we have to put do at the top, and then we have to put end at the bottom. So I'm going to say live loop, bass drum, do, and then when I go down here, it will sort of auto indent for me, which is very kind of it. And then I say end, and then it auto aligns that. And now if I run this, right, now this will just keep going indefinitely. So I'm gonna pause there, and I'm gonna see if anyone has any questions. And I'm gonna, wish I could see. Yeah, I'm gonna check the chat. I think that's gonna be the best thing for me to do, is to just sort of check the chat to make sure everyone is good on this, or to see if anyone has any questions about this. How do I do that? Okay, everyone feeling good? You can shoot me the thumbs up in your window if you're getting this, if you're still there. Cool, I see one thumbs up. See another. Cool. All good. Okay, great. I'm going to, at the top of my buffers, I like to put just a couple pieces of information just to make everything sort of at the right rate and that, sort of keep everything in order. So at the very top, I'm going to use a command called use BPM. And use BPM is talking about the beats per minute. So in music, we talk about tempo. Was the music slow? Was it fast? If you grew up in the classical music tradition, sort of Western classical music tradition, you might hear words like largo and allegro and andante and things like that. Sonic Pi doesn't know those, doesn't really care too much about those words. So it uses BPM, so beats per minute. And I'm going to use 132. So that means that in every minute, there's going to be 132 beats. And I'm choosing 132 not arbitrarily, but because that's sort of That's sort of a sort of canonical tempo for techno or house music. So I see we got some chat. Oh, cool. Yeah, everything's public domain. Feel free to use everything, make really cool music out of this, and not have to worry about that. So 132 beats per minute. That's what we're going to settle on. And so now we have like a sort of housey, sort of techie bass drum going. Okay, so that's cool, but you know, there's a lot more we can do. So let's add another instrument. Another instrument that goes well with kick drums are snare drums. So we're going to make another loop, another live loop. And we're going to call this snare. And then again, we're going to start it with a do. We're going to end the first line with a do. And then same thing, sample. And then here, we use drum, snare, and hard. Okay? So now we need to think about, where does the snare drum happen? So I'm going to comment this out just for a second. So to comment something out, you hold Command and then /, and that comments it out. So then that won't it won't run. That bit of code won't interfere, because if I try to run it with it, it won't do it. It'll sort of freak out on me. So I need to comment that out. So let's think about when the snare drum happens. So if I'm listening to this and I want to play a snare drum to it, or I want to add a snare drum to it, I'm think like, you know, 2, 3, right? Sort of happens every other time that the bass drum hits. So if the bass drum is sleeping 1, if that's its length, you would think that we would do sleep 2. So let's listen to that. So it's working, like it is happening every other one, but if you notice, if I start again, it's going to happen on the first one, and we don't want it to happen on the first one. So like, happen there, we don't want it to happen there. So what we need to do is we need to add a sleep in front of the sample, and then a sleep after. So now when we run it, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay. So I'm going to play with this snare drum sample just for a little bit, and try and get sort of a better sound out of it. Because right now, if I take this away, it's just a little bit too, it's a little bit too long. I want my snare drum to be a little bit shorter, like the sound of it to be a little bit shorter. So after I put a comma after a sample, then it gives me a whole list of parameters that I can work with here. And it's like, you know, if you've ever worked with like a DAW, like Ableton or GarageBand or Logic or Pro Tools or whatever, some of these things will be familiar to you. Like if you've worked with synthesizers like Attack and Decay, will be sort of familiar to you, and they work in pretty familiar ways. The HPF is the high pass filter, which only lets high frequencies through, and that has a whole bunch of parameters. And LPF is low pass filter. There's some slicing, there's some pitch, and there's a whole bunch of other stuff. The one that we're going to mess with is finish. So the way that this works, all these samples are a particular length long, and the finish parameter sort of normalizes all those lengths to the unit of 1. So so if I say finish at 0.5, that means that once the playback for that sample hits the middle of the sample, it'll stop. So if I play that now, Okay, and because this is live coding, I can change this on the fly. So if I put 2.5, rerun it, right, then I'm getting a much shorter sample. If I do 1.25 and run that, I get an even shorter sample. You can also, set the start. If you can set the finish, you can also set the start. But I'm going to do that for right now. I'm going to leave that at 0.125. I'm going to run this. So we're getting a little bit more techy. So that's cool, but everything is really stagnant right now, right? If we let this run, it's just going to play those same things over and over and over again. So we need to introduce a little bit of randomness. We need to give the computer some choices. So again, we're going to focus on this finish parameter. And what I'm going to do is I'm going to make a ring. And so in Sonic Pi, a ring is a collection of values. So if I go to the language, this might be a good opportunity for me to leverage the language. So ring is basically a list, it's an array. And so if you look down here, you basically just like fill it with numbers, and then you can have it do some different things with those numbers. You can either walk through those numbers, or you can have it choose different numbers from that. So I'm going to say ring, and then give it the numbers that we were working with, and then 1. And then I'm going to say tick. So what tick means is that the first time through, it'll use the first value, and the second time through, it'll use the next, and then the next, and then the next. Then it starts back over, does the first one, second one, third one, fourth one. So let's listen to it without the bass drum just for a second. Okay, so that's pretty cool. We put it back in with the bass drum. So it's giving it, some sort of motion, some sort of development, but I'm going to say choose. And now I'm telling the computer that it's free to choose whichever one of these numbers it wants to. Then I'm going to do the same thing up here with the bass drum. Oops, 0.5. Choose. Okay, I'm going to pause there and check the chat and make sure that everyone's feeling good about this, and everyone, see if anyone has any questions. And I'm also going to give you maybe just like a minute or two while I'm sort of checking in with people to feel free and start to play around with this. This is the great thing about Sonic Pi, is that if you have 2 minutes, you can just sort of fiddle and make something or break something and see what happens. Okay, any questions, or should I keep on trucking? Okay, cool. I'm going to keep moving. Okay. The only thing I'll say that's weird about teaching is I like to ask a lot of questions when I teach, and have sort of a back and forth. So this is just like this is great. I'm having a lot of fun. It just feels a lot different than like the other teaching that I've done. So if you know, if I get frazzled, it's just because of that, because I like to uh, ask a lot of questions when I teach. I used to teach a lot of little kids. I used to teach elementary school music, and you have to ask them questions constantly to keep them engaged. So I'm going to try to not think of you all as elementary school kids. I'm going to keep going. Okay, so if we have our kick drum and we have our snare drum, the next component that we're going to add in is going to be some hi-hats. Okay, so again, I'm going to make a loop, and I'm going to call this hi-hats. I'm going to say do, and then I'm going to go back to my samples, and there's a bunch of different ways you can make hi-hats. There's also a way to make it with white noise, if you know how to do that, white noise and some filtering, which is really fun, and maybe we'll cover that next week. But for right now, we're gonna go to, if I can type, drum, and then cymbal, and we're gonna say cymbal hard, since we use the hard snare drum. Oh, here's something that we can do. We can change the amp, which is the amplitude. This parameter goes from 0 to 1. You can also override it. You can increase the amplitude above 1 to get some distortion, which is sort of fun to play with. But for right now, we're going to keep this at 0.75. And then, actually, why don't we do this? Why don't we make this a ring? So 0. Let's see, what would our lowest one be? Maybe 0.5, then maybe 0.75, then maybe 0.1. Oops, sorry, 1.0, and let it choose that. Sleep. Again, we'll make another ring, and we'll say 0.125, 0.25, 0.5. Then we got to end it. So let's hear what this sounds like. Oops. Okay, so here's the cool thing about Sonic Pi is that it played everything that it could. It played the bass drum, it played the snare drum, it played the hi-hats once, and then it got to here, and it was like, I don't know what you want me to do, so I'm just not gonna do anything. I'm gonna play it once, and I'm gonna go sit down, because you didn't tell me what to do. So I forgot to tell it to choose. Ooh, that's not the one that I want. That's the one that I want, closed. Okay, it sounds bad. It sounds bad because even though this software is built for music, there is some syncing that we have to do, okay? So once you get a couple loops, and especially a couple loops that have small time values, small sleep values, we need to make something to sort of keep everything organized. So one trick is to make another loop at the top that we're going to call click. You can call these loops whatever you want, of course. I named them sort of what they are, just so I know what they are. So live loop click, do, and then just because I'm a little bit neurotic, I like to put my end first so I can see where my code blocks are. We got a chat. What's up? It sounds bad. Yeah, I love when music sounds bad when I'm making it, because then I get to figure out why it sounds bad and how I can make it sound better. It's just this continual process of, okay, it sounds a little bit better, but it still sounds bad. How can I make it much more better? So, okay, so we're doing this click. That's what I was talking about. So with this click, what I'm going to do is I'm not going to have it play anything. This is just sort of a silent click. So what I'm going to do is I'm going to say sleep and then 0, 1.25. Okay, and just to show you that it's actually doing something, I'll have it print, and I'll have it say click. And I think that'll work. And so if you look over here in my log, see we get all these clicks over there. That shows that yeah, it's actually running, and it's running consistently. And if I looked at the numbers really closely, I could see that it was happening, equally. So we have that click, and now we need to tell all these other things to sync to it. So I'm going to add a comma after the name. Then I'm going to say sync. And then I'm going to put another colon there, and I'm going to say click. Okay. So this is the only part that's a little bit tricky, just because like you have the sync parameter, and so after the parameter, you have a colon, but then you also need to tell it what to sync to, and so that starts with the colon too. So you have these sort of back-to-back colons, which it looks a little weird, but is just sort of how it has to live. So I'm going to copy this, and I'm going to put it there, and I'm going to put it there. And then if I run, everything should be synced to that click now. Okay, still sounds bad. Maybe we don't need this .125. Okay, sounding better. Everything's lining up. Things are working together. It's feeling good. So let's see, we're cruising. We got a lot of time left. So this is, I'm going to sort of ask you guys a question and see where you guys want to go. We could either talk about like view screen. If you have a screen, can you make it so that when you tell the program to print something, it would also show on the screen? That's from Frank. Frank, do you mean like an external screen, like another screen, or do you mean on your own screen?
I mean like an external screen.
I don't believe so. What you can do is you can have Sonic Pi send out OSC messages. OSC is Open Sound Control, and you can use that as a way to sort of send data between programs. So like a lot of times what people will do is when they do these live coding events, one person will have their laptop that has the music, they're coding the music, and then another person will have another laptop that's coding the visuals, and they'll be sending OSC messages back and forth to communicate that way. So if you had another program that was controlling another screen, you could send messages to it through OSC messages. That's a great, good question, thanks. Okay, I was gonna ask you guys a question, or you all a question. So we can either talk about sort of synthesizers and start taking a look at those synthesizers, or we could look at some effects that are built into this. So which one would you all prefer? Just drop it in the chat. Synths, okay, I see 2 synths. Okay, I see lots of synths, cool. That's great. Okay, so we're going to we're going to make another loop, so live loop, and we're going to call this one synth bass, because we're going to make it a bass. So we're going to use a command called use synth, and then there's all these synths, and some of them tell you a little bit about what the sound is going to be like. So like Pretty Bell is going to sound like a pretty bell, and there's piano, which is going to sound like a piano, even though it doesn't really sound like a piano. Then there's a saw, which is just going to sound like somebody sawing, which is not true. That's a joke. The good thing about this is that I can't hear when you're not laughing at my jokes, and so I'm going to imagine that everyone's laughing. Okay, so we're going to, I'm not going to check the chat because I'm sure it's just people saying stuff. So the synth that we're going to use is the FM synth, which is what a DX7, some of you heard us talking about DX7 synthesizers at the beginning of this. DX7s are DX7s are based on this idea of frequency modulation, which we're not going to get too far into, but it sounds cool. And so after we put FM, then we have, oh no, we can't do the parameters there. We'll do the parameters somewhere else. So then we say play. And here's a new thing that we haven't done because we haven't played a note yet. We've just used samples. So instead of using sample, we're going to use play. And after we say play, we can put in a couple different things. So we can put in a number. So if I put in 44, then I say sleep, and I say 0.5, and I say end. And actually, I'm just going to take all this away just for a second. Okay, so we have that, which is just playing note number 44. Now, which note is note number 44? There's two possible answers for that. The first possibility is I don't really care. Like, you don't have to really care. That's sort of the beautiful thing about this software, is that like you don't need to know anything about music. You just say play this note number, and then you say play this other note number, and then you get to decide if you like that or not. You can do like note number 44 and note number 48 don't sound good together. They might, whatever, you get to choose. Or what you can do is you can go onto the internet and find the list of MIDI notes. So MIDI is a hardware and software interface language. There's a better word for it that I'm forgetting. But basically, every note on the piano and every sort of note in the world is assigned a particular number. And all these manufacturers have agreed that whenever we say note 44, we all mean whatever it is. What note is this actually? I have my keyboard right here. So that's like it's like a B flat. And you can know that or not know that. So we can also do this, B flat 3, or if we change it to B flat 2, or we change it to B flat 1, or if we change it to B flat 0. Okay, it's going to sound better wherever you are because my microphone's not going to pick that up that well. But so this this sort of syntax is sort of grown out of music theory, where C4 is middle C, and then B4 is the note below middle C, B flat 4 is a note below that, and then it goes to A4, and then the note below that is G sharp 3, and below that and below that and above, whatever. So you can either know that too, or you can just be like, I like E3. E3 feels good to me, and so I'm going to use that. So, so yeah, and again with this, so we can make a ring, and we can say E flat 3. Let's make a G3. Oops, G3. Oh, another great thing. See, I caught that I forgot that little colon, not because I'm really good at this, but because if I don't put the colon, it's not pink or whatever color it is on your computer. Okay, so that's another cool thing that Sonic Pi does. So if we wanted to have an F sharp, if we do that, that's not going to work. We got a chat. What's up? Capitalization matters. Luckily, capitalization in notes does not matter. So, so if I want an F sharp, I have to put FS, S for sharp, because the pound or the hash is used for that. Okay, so I have those notes. Then I'm going to say, actually, I'm going to put in one more. I'm going to put in B, oops, did it again. B3. And I'm going to say tick. Then if I, oops, then I'm going to say sync, click. So now it's syncing to that. And then if I add the kick drum, oops, I messed that up, sorry. Okay, there's, to get to the point where you can perform at this live, there's a couple extra things that you need to do, including building out sort of a better time management system so that things start, you know, on the downbeats when they're supposed to start on the downbeats, or start at the beginning of 4-bar phrases if they are supposed to start at the beginning of 4-bar phrases. So, so yeah, so but if we just sort of play this all together. Okay, it's pretty cool. We actually have some semblance of music happening. Now, another thing that we could do instead of using the play, oh, I see some questions. Batch annotation. Yuchen, can you tell me a little bit more about what you mean by that? Oh, so highlight stuff, then hit Command if you're on a Mac. I'm on a Mac, hit Command, then /. And that'll take it in or out. Okay, Will says, is there a way to visualize the length of all the loops to figure out how in and out of sync they are? Not really. Yeah, there's not really. What you can do, I went over to my preferences a couple days ago and turned some things off in the log because I was sort of getting overwhelmed by that. I'm going to take that click out. So now if I run it, I'm going to sort of turn this down. So you can see that how things are running over here. That doesn't give you a very good, it doesn't give you a very good idea of like how in or out of sync these things are. That is a little bit more, you have to use your ear and be a little bit more intuitive in that way. Good questions. Thanks for the questions. How do you stop a specific loop? Ooh, I forgot to talk about that. Thank you for asking me that. So, if I don't want the bass drum in anymore, all I do is say stop. Then when I want it to come back in, see I commented out the stop. Then when I want it to come back in, try and get it right. 2, 3, 4. Oops. You know what would help is if I made my click, the duration of my click larger. So let me try this again. So it stopped. 1, 2, 3, 4. There we go. That's better. Good questions. Keep the questions coming. So it has to be live. You can't run an entire code like recorded music. Yeah, you totally can. You can have things where, how do I want to do this? If I say, yeah, you can build up like data structures for it to choose and count, you know, lengths of time that have elapsed and choose different parameters. So here's what we'll do. We'll do this thing called 16 times do. So that means that it'll choose 16. How do I want to do this? And then if I do end. So it'll run this part 16 times. And if I copy this and I change these to, let's say, B, D, C sharp, and F sharp, oops. Then, so it'll do this part 16 times, and then after that, it'll do this part 16 times. So for that, you can have, that's just sort of one way to have things lined up and ready to go. So now if I run this, then it'll change. Then it'll loop back. Yeah, good questions. Does that make sense? These 16 times, you can make this whatever you want. You can have this be one time, and it'll only run this block of code once. You can have this be that many times, and it'll just count. It just counts, it doesn't matter. It's totally happy. But yeah, reiterate what a ring does exactly. Yeah, so a ring is a list. You can also call it an array. Basically, the ring just holds values. They could be, like in this case, they're the notes that you want. Up here, it's the values for the amplitude, so how loud or soft. And then after it, you have to tell it how to move through that list. So you can have tick, which goes first one, then the next one, then the next one, then the next one. Or you can have choose, which the computer then gets to choose whichever one it wants in whatever order it wants. Great. We have like just 2 minutes left. I'm hoping that this was enough just to like whet your palate and get you sort of interested in making music this way or using the software. Can I add in voice recordings? That's from Zion. Yes, you can. You can add in your own samples. That I'm going to add that to my list of things to talk about next week. Because I haven't really done that much. But I'll get really good at it and do that. Yeah.